you will access the object that contains your Lambda expression. You are not accessing the Lambda function object that generated. So you cannot have a recursive Lambda expression. With explicit object parameters, you can. So here I have a Fibonacci Lambda expression, and I'm using an explicit object parameter, this auto self. And once I have this inside the body of my Lambda expression, I can call self. So I can call the Lambda expression can recursively call itself. Next one, if const eval. What is the syntax? It's straightforward. You just write if const eval A, else B. As you can see, there is no condition. It's just called if const eval. The braces are mandatory. With a normal if statement, the braces for if there is a single statement, you don't need them. In this case, they are mandatory. And what's the effect of this? The effect is that if this statement is executed at compile time or in a constant evaluation, then A is executed, otherwise B. So why do we have this? Because we already have a function in the standard library called isConstantEvaluated. So what is wrong if you write if isConstantEvaluated A, otherwise B? Not much. It's actually equivalent, almost equivalent. If const eval is part of the core language, you don't need to include any header files or any modules. Within an if const eval block, you can call other const eval functions, which is not possible if you use the isConstantEvaluated. And maybe more importantly is that if const eval cannot be used wrong, while if isConstantEvaluated can. Because I've seen that some people think that isConstantEvaluated need to be written like at the bottom line, so if const expr is constant evaluated. But obviously, if const expr will execute at compile time, and at compile time, isConstantEvaluated would always be true. So that last statement is the same as just writing A, B will never be executed. So here is an example. I have a const eval function f, also called an immediate function. I have a const expr function g, and in this const expr function, I can check if I'm being called at compile time or not. So one thing, const eval functions, they are guaranteed to be executed at compile time, while const expr functions can be evaluated at compile time or at runtime. So if you want to execute a const eval function from inside a const expr function, you need to make sure that you are in a constant evaluation context, and you can do that with if const eval. So here in the if const eval, I'm calling my f immediate function. In the else statement, for example, in the else block, I would not be allowed to call f. I have a third function, h, which is also an immediate function. Yeah, and this one obviously can always unconditionally call other immediate functions. This is also a nice one, multi-dimensional subscript operator. In the past, if you had multi-dimensional data, you had two options. You can either use the function call syntax to access an element of your data, or you can use multi-level indexing. Now in C++23, you can have proper multi-dimensional subscript operators. And implementing them is straightforward. You just implement your operator square bracket as you're used to, except instead of accepting one index, you accept as many indices as you need. And in this case, I accept 3 to access a 3-dimensional data structure. Attributes on Lambda expressions. Before C++23, it was already possible to add attributes for your Lambda expression, and you specify them behind the parentheses. And the meaning of this is that the attribute has an effect or on the function object that is generated from your Lambda expression. So here I'm saying, yeah, the Lambda expression or the generated function object is deprecated. Now, at C++23, you can put your attributes on 2 places. So the first place is the same. You can put them behind the parentheses, and then it's the same as before. So it's an attribute specified on the function object generated from the Lambda expression. But now you can also put them before the parentheses. And then this attribute is an attribute on the function call operator of the generated function object. And like in this example, you can combine them. So here I'm saying that this lambda expression is deprecated, but if you still call it, you are not allowed to discard the value that is returned by it. So these integer literal suffixes have been there for a long time. So you have u, l, ul, and so on. New in C++23 are the following two. You have uz and z. And uz allows you to make a size t integer literal